Imagine a manufacturing plant running real-time inventory sync from the factory floor to Azure. During peak hours, a site-to-site VPN jitters, caused by nothing more than public internet congestion. Inventory records show out of stock while shelves are full. Production halts. This isn't a cyber attack, it's an architecture oversight. By the end of this video, you'll know how to build a hybrid network so that a backhoe in Dallas or a congested ISP doesn't wipe out a production line. And you'll have the skills that command a six-figure salary for that knowledge. Whether you're connecting a small branch office, a manufacturing plant, a hospital, or an entire enterprise data center to Azure, one decision affects everything that follows. Should you use a site-to-site VPN, ExpressRoute, or both? Choose the wrong architecture and users experience slow applications, unpredictable latency, and costly outages. Choose the right one and your applications remain available even when an ISP fails, a fiber cable is cut, or an entire circuit goes offline. By the end of this video, you'll understand not only how each technology works, but why experienced cloud architects choose one solution over another. Automation and AI are already handling a growing share of Tier 1 tickets. The real career growth is moving from triaging those tickets to designing the hybrid circuits that keep the business running. Site-to-site VPN, ExpressRoute, ExpressRoute Direct. That's where the higher salaries are, not in ticket triaging roles. Before you touch a console, here's what you'll walk away with. 1. You'll know exactly when to pick a VPN, ExpressRoute, or ExpressRoute Direct. 2. You'll configure a VPN gateway with BGP and an ExpressRoute circuit with private peering. 3. You'll present this as a career-proof portfolio piece that carries more weight than a certification PDF. Picture a manufacturing plant running real-time inventory sync from the factory floor to Azure. Every time the public internet gets congested, the VPN jitter spikes. That's sudden variation in packet delay, making data arrive out of sync. Operators see stock unavailable, even when parts are on the shelf. That's why a private, dedicated circuit exists. ExpressRoute is the answer for deterministic performance, bypassing the public internet entirely. Let's lock in the first lesson. Answer this before you move on. ExpressRoute gives you a dedicated connection through a partner completely off the public internet. You choose between Layer 2, switching frames within a single broadcast domain like a giant managed switch, or Layer 3, routing packets across subnets like a router. To meet the high availability SLA, many architectures deploy both primary and secondary connections. Bandwidth scales from tens of megabits to 100 gigabits per circuit, depending on the plan. No contention, no variable hop count, just predictable, enterprise-grade performance. ExpressRoute Direct gives you a physical pair of ports, 10 or 100 GBps, directly in a Microsoft peering location. You can create multiple virtual circuits limited only by the port's capacity. MACsec, Media. Access Control Security is a point-to-point encryption standard that secures data right at the physical layer, preventing eavesdropping on the wire. Direct is intended for large-scale enterprises that need high throughput and direct control, often when they already have connectivity to the peering location. For most organizations, a standard ExpressRoute circuit is the right choice. Let's lock in the first critical fact. Take a moment and answer this. Instead of clicking through the portal, let's deploy a VPN gateway in Bicep. This turns a one-off ticket into a reusable tested infrastructure module, the exact opposite of Helpdesk toil. The snippet below creates an active-active BGP-enabled gateway. BGP, the Border Gateway Protocol, lets your on-premises and Azure networks automatically exchange routes, avoiding static routing. Notice the ASN. Choose a unique value from your private range, not the Azure default. The gateway subnet and public IP are in separate resources, which makes the whole thing self-documenting. No mystery. Here's exactly where the BGP checkbox lives. BGP, Border Gateway Protocol, allows Azure and your on-prem network to exchange routes dynamically, so you don't manually update static routes. On your VPN gateway, go to Configuration, flip BGP on, and type your on-prem ASN 65501. Then pop over to the local network gateway and fill in the BGP peer IP and its ASN. Once both sides match, the peering comes up. This 1-minute walkthrough demystifies the whole process. Before we dive into the mistake, let's ground BGP. Border Gateway Protocol is the routing engine that lets Azure and your on-prem routers share route tables automatically. No manual route table entries. Now here's the mistake that kills that session before it starts. Azure's VPN gateway defaults to ASN 65515, a reserved value. If you accidentally assign the same 6551 theme to your on-premises router, the BGP session will never come up because both sides think they're talking to themselves. The fix. Pick an ASN from 65020 to 65514, or any private ASN range, and one more footgun. BGP only works on a route-based VPN gateway. Policy-based won't even let you tick the box. This is the single most common repeat mistake I see in production configs. Knowledge check. Checkpoint. ASN Collision. Remember that manufacturing plant struggling with VPN jitter? They moved to ExpressRoute, and their inventory sync became rock solid. Let's look at what actually sits underneath. 3 objects make it tick. The ExpressRoute circuit itself, a dedicated link through a partner, an ExpressRoute gateway inside your VNet, and a connection tying the two together. Your on-prem Edge router peers with Microsoft's Enterprise Edge, the MSEE, using BGP, and can assign a VLAN ID for traffic segregation on the physical line if needed. Private peering exchanges route tables between your on-prem network and your VNet's theater space, bypassing the public internet. That's why the plant's latency, previously suffering from variable VPN spikes, became reliably low. But here's the part almost everyone gets wrong. Imagine a financial services firm with a single ExpressRoute circuit for payment processing. One morning, a construction crew accidentally severs the provider's fiber conduit. No backup VPN exists. For an extended period, transactions stop, costing significant revenue. The hard truth? Even a dedicated circuit rides a physical cable. Without an encrypted internet backup, you're one backhoe away from a business disaster. This is where the combined model saves careers, not just data. The fix for that bank's nightmare is a coexistence design. You place both an ExpressRoute connection and a site-to-site VPN on the same gateway. BGP advertises the same on-prem prefixes across both links, but you prepend a couple of extra AS hops to the VPN advertisement so its path looks longer. Under normal conditions, ExpressRoute is the winner, and all traffic flows through that private circuit. The moment that circuit drops, BGP withdraws its routes, and after BGP reconverges, the VPN path takes over automatically within a few minutes. No manual intervention, no missed payments. This is the blueprint for any production-grade hybrid network. Now that you see the resilience pattern, let's talk dollars. For a sustained 500 megabits per second, A site-to-site VPN with 2 gateways and egress will run you roughly $550 a month. ExpressRoute at the same throughput clocks in around $1,700 a month. The price of dedicated predictable latency. ExpressRoute Direct, a 10 gigabit port where you carve multiple circuits, starts near $4,500 a month, but amortize that across 50 workloads and the per bit cost plummets. Latency, VPN typically sees 15 to 25 milliseconds. ExpressRoute chills at 2 to 5 milliseconds inside the same region. That gap is the difference between a real-time trading app working or failing. Is cost the highest priority? Choose site-to-site VPN. Is predictable latency required? Choose ExpressRoute. Does the application support mission-critical business functions? Deploy ExpressRoute with VPN backup. Do you need massive throughput across multiple circuits? Consider ExpressRoute Direct. There's no universally best option. The best architecture is the one that meets the business requirements while balancing cost, performance, availability, and operational complexity. One of the biggest misconceptions in enterprise networking is believing that a private connection automatically makes an environment secure. ExpressRoute removes your traffic from the public internet, but it doesn't verify who is using that connection. An employee with stolen credentials can still access sensitive systems. A compromised server can still attempt lateral movement. A malicious insider can still reach critical resources. That's why modern Azure architectures combine network security with identity security. Instead of trusting users simply because they're on the private network, Azure verifies every user, every device, and every application before granting access. ExpressRoute protects the transport. Zero Trust protects the identities using that transport. The strongest enterprise architectures always combine both. A certification tells someone you studied. A GitHub Actions workflow that deploys a full hybrid network, tests it, and publishes the results tells them you can do the job. Here's a real pipeline. It checks out your Bicep templates, authenticates to Azure, and deploys both a VPN gateway and an ExpressRoute gateway in one shot. Then it runs an Azure Network Watcher connectivity test that verifies traffic actually flows across your links. Finally, it uploads the test results as a portfolio artifact, a concrete, verifiable asset you can link in a resume bullet. When a recruiter asks for hybrid cloud experience, you point at a commit, not a PDF. ExpressRoute isn't purchased because it's faster. It's purchased because downtime is expensive. Imagine an online retailer unable to process orders during Black Friday, a hospital losing access to patient records, a financial institution unable to process transactions. For these organizations, even a few minutes of downtime can cost far more than an ExpressRoute circuit. Cloud architects don't recommend ExpressRoute because it's an impressive technology. They recommend it because the cost of failure is much higher than the cost of prevention. Understanding that business perspective is what separates architects from administrators. Head to the portal, search for ExpressRoute Circuit. Pick your subscription and resource group, choose a provider like Equinix, set bandwidth to 200 Mbps, standard SKU. Once the circuit is provisioned, open peerings, add Azure Private. Use VLAN 100, enter your on-prem ASN, and Microsoft's side will already show ASN 1-2076. Drop in the 30 subnets for primary and secondary links. After saving, you'll see the peering status flip from not configured to provisioned. That's your green light. Here's the Bicep. First, create a VNet with a gateway subnet. That's where the ExpressRoute gateway lands. Deploy the gateway using a SKU that supports private peering. Standard, high performance, and ultra performance all work. The gateway type is ExpressRoute, not VPN. Choose the SKU that matches your throughput needs. Finally, create a connection resource that binds the gateway to your circuit by referencing the circuit resource ID. BGP comes alive as soon as private peering is configured on the circuit itself. Knowledge check. Checkpoint. Gateway configuration detail. Instead of babysitting a dusty on-prem rack, spin up a full hybrid Azure lab with a single Bicep command. Validate ExpressRoute, VPN, and failover in 2 hours, then delete the whole thing. You never pay for idle hardware, and you get muscle memory repetitions that a static lab can't give you. When the ExpressRoute circuit fails, BGP withdraws its learned routes automatically. Within minutes, traffic shifts to the S2S VPN tunnel. No manual failover. Meanwhile, Azure Site Recovery, ASR replication, ensures your critical VMs stay synchronized to a secondary region. Document this flow, and you've got concrete proof you can handle a real disaster. This route table forces the 10.01.0 subnet through the virtual network gateway. Combine it with a more specific BGP prefix advertised over VPN, and you've steered sensitive traffic into an IPsec tunnel while everything else keeps the low-latency ExpressRoute path. Assign this route table to a subnet, and Azure does the rest. Let's reinforce the practical routing trick you just saw. Not every company needs ExpressRoute. In many environments, a site-to-site VPN provides excellent performance at a fraction of the cost. ExpressRoute becomes worthwhile when applications require predictable latency, high availability, regulatory compliance, or dedicated bandwidth. Examples include financial trading systems, healthcare applications, large ERP platforms, manufacturing systems, enterprise backup and disaster recovery. If your workload can tolerate occasional internet variability, VPN is often the smarter choice. If downtime directly impacts revenue or safety, ExpressRoute quickly becomes the better investment. Architecture is about choosing the right tool, not always the most expensive one. Coming from Tier 1 support isn't a liability, it's your edge. You know exactly how a flaky network feels to an end user. That empathy lets you design hybrid connections that alert you faster when BGP flaps, that have clear troubleshooting paths. Executives don't care about packets per second, they care about mean time to detection. You can speak that language. If you're learning Azure networking, here's a progression that mirrors what many engineers follow. Start by deploying a site-to-site VPN between an on-premises lab and Azure. Once you're comfortable with gateways and routing, enable BGP and observe how routes are exchanged automatically. Next, study ExpressRoute architecture and understand how private peering differs from VPN connectivity. Finally, build a complete hybrid environment that includes VPN failover, network watcher diagnostics, infrastructure as code, and documentation in GitHub. Each project builds on the previous one. By the time you finish, you'll have a portfolio that demonstrates real networking experience, not just theoretical knowledge. 5 tools that turn architecture guesswork into precision. The pricing calculator models your exact ExpressRoute circuit cost before you open a support ticket. Network Watcher troubleshoots VPN and ExpressRoute connections in minutes, not hours. The Bicep extension gives you auto-completion and validation as you write infrastructure code. GitHub Copilot takes Bicep even further. It generates entire gateway configs from a comment. And AsCopy measures real throughput to your storage account so you can prove your circuit delivers what you paid for. Each one saves you from the worst kind of troubleshooting, the blind kind. This table is your cheat sheet when someone asks what to use. S2S VPN gives you an encrypted internet tunnel for peanuts, perfect for a branch with 3 POS terminals. ExpressRoute is the private highway. Predictable latency, SLA, no internet contention. ExpressRoute Direct is for when you already own the fiber and want to slice unlimited circuits from a single 10 or 100 gig port. The key takeaway: start with VPN, move to ExpressRoute when the business can't tolerate jitter, and go direct only when your WAN budget justifies a full port. Time for a quick reality check. This is exactly the kind of question you'll get in an architecture interview. A dental lab in Ohio processes 4K X-rays overnight. Every night, the owner watches uploads crawl over a site-to-site VPN. Timeouts, retries, a sync window that bleeds from 2 hours to 4. One Tuesday, he loses a full night of work. He fires the ISP, orders a 50 megabit ExpressRoute circuit, and suddenly those same X-rays transfer without a hiccup. Jitter vanished. He gets 2 hours of sleep back every night. The lesson: a tiny dedicated circuit can out-reliability an internet VPN by a mile. Don't wait until your workflow breaks to learn it. Gateway sizing decides whether your ExpressRoute delivers gigs or chokes. The high-performance SKU supports up to 2 gigabits per second of ExpressRoute throughput, solid for most enterprise workloads. The ultra-performance SKU, when paired with FastPath, can handle up to 10 gigabits per second and bypasses the gateway entirely for north-south traffic, removing a major bottleneck. FastPath is the toggle you enable when you're moving real data, medical imaging, seismic analysis, nightly backup copies. If you're designing for a power grid, you spec ultra-performance and flip FastPath on day 1. Anything less and you'll hit a wall during the first DR test. If you're wiring a bank, a single ExpressRoute circuit is a single point of failure. Unacceptable. The blueprint: 2 circuits from different providers, each entering a different MS edge, plus an S2S VPN as the tertiary safety net. BGP local preference selects the primary provider. If a backhoe takes out one fiber conduit, the second circuit takes over in seconds. The VPN sits cold but ready. This is the architecture you present when the CSO asks, "What happens if the entire provider goes dark?" One more trap that separates architects from ticket takers. Instead of sending a PDF certificate, you send a link to this GitHub repo. The Actions tab shows a workflow that stands up the entire hybrid lab. Hub VNet, VPN gateway with BGP, ExpressRoute gateway, failover test, in under 20 minutes. The PR has a comment from you documenting the failover test result. A hiring manager sees a proven builder, not someone who studied multiple choice questions. That's the portfolio piece that justifies a $165,000 salary floor. Let's review what you've accomplished. You now understand when to choose a site-to-site VPN, ExpressRoute, ExpressRoute Direct, or a combination of all 3. You know how BGP exchanges routes automatically between Azure and your on-premises network. You understand how private peering connects enterprise networks without traversing the public internet. You know why redundant circuits, VPN failover, and infrastructure as code are considered best practices for production environments. Most importantly, you now understand the architectural reasoning behind these technologies, not just the portal clicks required to configure them. That's the difference between memorizing Azure services and designing enterprise solutions. You've wired your data center to Azure with resilience. Next, you need to distribute that traffic inside your VNet so a single VM failure doesn't take down your app. Part 7 tackles Azure Load Balancer, Layer 4 distribution, health probes, and high availability patterns that keep your VMs running when one, inevitably, dies. Hit subscribe so you don't miss it. And if this video earned a sub, drop a like so YouTube knows. It helps real people landing real cloud jobs. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.